For today, I can solve and graph quadratic equations by factoring quadratic formula and completing the square. And of course, we're going to be graphing situations with real-world problems. Okay? Do we need a Ferrier model? No, because we already know what quadratic equations are. We don't need any steps because by now we have all the methods and everything in our noodle. So today we're going to put together all that with word problems. So I do want you to title your paper for today. Title it Applying Quadratic Equations. And within that, I'm going to give you also one problem that is a system, including a quadratic equation in application. So let's move on right away to a word problem. Example Q. Copy this. It says, I know, right? Didn't I say I was going to crank it like this? Bam. It says, example Q. A ball is shot from a cannon into the air with an upward velocity of 32 feet per second. The equation that gives the height h of the ball at any time in t is h of t equals negative 16t squared plus 32t plus 48. Part A, find the maximum height attained by the ball. Part B, how long will it take the ball to hit the ground? And then here's an illustration. I included that so we can talk about it right now once you're done. But copy that for right now. And if you want to do the illustration on the side, that's fine. Copy that. All right, so let me break down this problem really quick just to make sure we understand what we're looking at, okay? So the problem says, again, a ball is shot from a cannon into the air with an upward velocity of 32 feet per second. The equation that gives the height h of the ball at any time t is h of t equals negative 16t squared plus 32t plus 48. Find the maximum height attained by the ball, and how long will it take the ball to hit the ground. Now, I'm going to come back to this illustration, but if I was to sketch here the rest of it, let me see. I would draw a, let's see, here's a triangle here, triangular base, and then the cannon is pointing upward, something like this. Have you guys seen those cannons that swivel like that? And then they have the little, this is lit. You have the fuses right here, it's lit. And it's lit, and it's going to project the cannonball upward, and then it's going to fall over here. So that's the illustration. And tonight's home play, you're going to have 3 word problems where one of them I wanted in the illustration. You're like, wait a minute, does that mean we're like there, Mr. Q? Yes, we are there. Oh, yes. Oh, that's a good idea, Luca, for Presidente. You don't have to do a poster like that. That's if you want extra credit, that's fine. But if you want to illustrate it, not if you want. One of them has to be illustrated on your paper. All right? So is this a good illustration? Here's the ball, projected, goes up, and it falls over here. Okay. So let's see what they're asking us. Find the maximum height. Looking at this, does everybody see the maximum height?
No.
The maximum height is there. Before I continue, think about it. Don't say it out loud. What's another word that we use for maximum height? Don't say it out loud to yourself. Okay, talk it over to your neighbor. What's another word we use? Everyone. That is correct. Label this one Vertex. And it's going to be a coordinate. What else can we label? How do we find the x value of the vertex? Who can give me that equation so that people can have that there handy before we get started? Jason.
X equals minus 3 over 2.
That is correct. That's what we're going to use to find the x value of the maximum height of that cannonball. All right, let's break down the second part. How long will it take the ball to hit the ground? What does that mean? How long will it take? So look up, please. When does it hit the ground? Right here. Is that correct? Where did it start? Over here. So look at this. Look up, guys. What does this point and this point, what are those called? Tell your neighbor, please. Everyone. So make a little note for yourself right here. Write x intercepts, which means how long will it take to take the ball to hit the ground? That means we need to find our intercepts to figure that out. And how do we do that? By solving our what? Our quadratic equation. Now, some of you are still wondering, Mr. Q, but this gets me confused. Look up the 32 feet per second. Well, this is only part of the first part of the word problem. This is just explaining how fast the ball was going. So it says, check this out. This is the introduction. It says, a ball is shot from a cannon into the air with an upward velocity of 32 feet per second. So you're saying, do we need to make that into an equation? No, that's already included in the equation. Look at the equation. Do you guys see it? Tell your neighbor where it's at, please.
32t.
That is correct. That's the middle term of your equation. Okay? So now, before we move on to solving the equation to find how long it takes to hit the ground, let's find the vertex. So I'm going to do the work over here. Vertex, I'm going to do that in blue. Vertex. So to find x, we said we write x equals minus b over 2a. All right, according to our equation, what is b? Fatima. That is correct. So we write negative parentheses 32 times 2 times, what is a? Paul. Negative 16. That is correct. Negative 16. So let's see. Negative 32. 2 times negative 16 is negative 32. So what is negative 32 divided by negative 32? 1. Made a mistake?
Yeah, it's actually regular 32, not negative 32.
Let's find out.
Negative times the negative equals positive.
Well, let's find out. Part of the formula was negative, right? Here it is. What is b?
32.
So what is negative times 32?
Negative 32.
What is 2 times a? What was a? Negative 16. So what is 2 times negative 16?
Negative 32.
So what is negative divided by negative? Positive 1. There it is. Okay? But now we need to find our y value. You're saying, Mr. Q, but this is not in terms of y and x. So can you help me change this into terms of x and y? Let's see, help me change this to terms of x and y, bless you. Reagan. So that people can understand, can we change this to terms of x and y? Okay, tell me what you write. Bless you. That becomes what? Yeah, but instead of that, what variable is it? Does that look a little bit more familiar? Yes? So now to find our y value, what do we substitute? Everyone? X into there. So it's y equals negative 16 times 1 squared plus 32 times 1 plus 48. That gives me y equals, what is 1 squared? 1 times negative 16. Negative 16 plus 32 plus 48. Y equals negative 16 plus 80. So what is negative 16 plus 80? 64. And that goes right here.
Nintendo 64.
Damn. What? All right. Look up, please. Remember, what are we working out right now, all this? Because we're trying to find the maximum height attained by the ball. So what is our maximum height? 164, which is this point right here. 1, 64. But the 1 means something and the 64 means something. Don't say it out loud. Keep it to yourself. Think about it. If this point right here that it's plotted is 164, what does the 1 mean and what does the 64 mean? Talk it over to your neighbor, please. What does the 1 mean and the 64? Let's see. How about Isaac? What'd you get for, what does that mean, 1 and 64? Okay, here it goes again. We're answering part A, which is find the maximum height attained by the ball. And this is the coordinate for the maximum height. Okay. Okay, talk it over again with your neighbor. Look at part A, and what does that mean? Let's see. Destiny, enlighten us. In 1 second, the ball goes 64 feet high. That is her. That is correct. I'm enlightening you. I see the light. This is you. Hold on. In what? Oh, you said that? You said in 1 second? In 1 second, it hits the height of 64 feet. That is correct. Write that down, please, and answer the question in a sentence. Find the maximum height attained by the ball. The maximum height attained by the ball is 64 feet. They're not asking you for the time, but I just wanted you to interpret that coordinate. Yes?
It says it takes 32 feet per second.
$32 feet per second.
Yeah. And 32 feet should take 1 second. So if you would multiply that by 2, then it would be 54, and it should be 2.
It should be 2. So there's probably some computation mistake, but for right now, let's keep the 1 second and 64. All right. So now we answered the question in regards to the height. What is the second question? How long will it take to hit the ground? So look, we need to find this part. So what do? Let's get our equation. We're going to leave it in terms of x and y. Let's see. Reagan again. X and y terms. Go. Very good. Y equals negative 16x squared plus 32x plus 48. Okay, hold on. What do we do from there to solve this time? We can do completing the square, but before that, what is the first step in solving any quadratic equation, everyone? Standard form, and change y equal to 0. 0 equals negative 16x squared plus 32x plus 48. Okay. From there, last week I said one of the things that we forgot to check before we started solving was to see if it had what? Everyone. Greatest common factor. So what would be our greatest common factor for all three terms? Negative 16. And we're left with x squared minus 2x minus 3, and all that equal to 0. What do I do from there, Luca? Look at it. And now? That is correct. Negative 3 goes on top, negative 2 goes on the bottom. Factors of negative 3 that add up to negative 2, 1, and negative 3. So we're going to rewrite this. X squared plus 1x minus 3x minus 3. Let's group these two and these two. So what is GCF for these two? X plus 1. What's GCF for those two? Negative 3, x plus 1. So my factors are x plus 1, x minus 3, and don't forget your what? Your BFF, which is negative 16 and equal to 0. What's the next step? You down with ZPP? Yeah, you know me. So that means each one of these three factors equal to 0. Negative 16 equal to 0. X plus 1 equal to 0. And x minus 3 equal to 0. Question. Is negative 16 equal to 0? No. So will this work?
No.
No. So we got rid of the BFF. That's it. They're gone. Minus 1, x equals negative 1. Plus 3 plus 3, x equals 3. Now, before we answer the question, look up to the screen. What was the question? The second question? How long will it take the ball to hit the ground? Look at these two answers. Tell your neighbor which one we won't use. Which one we won't use and why.
Negative 1 equals to negative. And it goes back.
Alright, let's see. Which one won't we use? Go ahead, Samantha. Why negative 1? Because negative 1. Yeah, but what's so special about negative 1? Why can't we use it? Upper Opry? You can't have a negative second unless you're, what's that guy from the Avengers? The guy that goes like that and then opens up the warp zone or whatever. Dr. Strange. We don't have capabilities of moving time, right? So that means we don't use this one. Oh, sorry. We don't use this one. Cross this one out. So that means it must take how long? Second. So answer the question. How long does it take the ball to hit the ground? You're going to write the ball will take 3 seconds to hit the ground. 10Q. So a couple things that I just wanted to make sure that you saw before we do another quick example. Look up. What is the first thing that we needed to note? That maximum height is, in other words, the what? The vertex, and we know how to find that. And then the second question, When they're asking how long will it take, that means we need to solve the quadratic equation and find our roots. Are you with me?
Yeah.
All right. Example super cute. Don't copy the problem, just copy the equation. Hurry up, hurry up. Example super cute. Don't copy the problem, just the equation. I'll read the problem out. It says, Angelique hit a golf ball from the ground and it follows the projectile with this equation, h of t equals negative 16t squared plus 100t, where t is the time in seconds and h is the height of the ball. Find the highest point of her golf ball. What does highest point mean? Tell your neighbor. Then it says also when it hits the ground again. That means we're going to solve for t or for x. Everybody with me?
Yeah.
So for right now, we're not going to find the vertex just to save time. Let's solve the equation though. Let's see. Let's rewrite this equation in terms of x and y so it can look more familiar. Fatima, tell me what you write. Copy that, please. That is correct. And once again, step one is what? Standard form, and it has to be equal to?
0.
That is correct. 0 equals negative 16x squared plus 100x. So now let's check to see if there's a GCF. Is there a GCF for these two terms? Yes. What would be? Somebody said 4, but the leading coefficient has a negative, so it's what? Negative 4. What else do both terms have? X. That is correct. That's our GCF. So negative 16 divided by negative 4, that's 4. X squared divided by x is x. 100 divided by negative 4, that's negative 25, and we already have the x out here, and all that is equal to 0. You're saying, this one looks kind of weird, Mr. Q. We can't use Power Rangers anymore. No, we can't, because it's already factored for us. You see how we have two factors? So now we're at what? You done with ZPP? Yeah, you know me. So this equal to 0, negative 4x equal to 0, and this equal to 0. 4x minus 25 equals to 0. All right. So let's see. Let's solve this. Divide by negative 4. So x equals 0. This one is plus 25 plus 25. 4x equals 25. Divide by 4. X equals 25 divided by 4 is 6. That's 24. 1 divided by 4 is 0.25. Okay. So let's look at the question. It says, find when the ball hits the ground. Okay. So let's picture this. They hit the golf ball. Here it goes. It starts here and it ends here. Tell your neighbor which one is which from what we got and what does that mean. Okay, let's see. Marissa, which one is this one? 0. What does that mean? In what? But this is in terms of what? Feet or time? Time, that is correct. How much time had elapsed before they hit it? 0. After they hit it, how much time elapsed, everyone?
8.15
seconds. That is correct. Are we following? Yeah? Okay. Last but not least. Example omega cube. Yeah. Systems of equations. Yeah. Okay. You're not going to copy the whole problem, but write your utensils down, look up to the screen. Now, let me show you the situation here. It says, a rock climber is pulling his pack up the side of a cliff that is 175 feet tall at a rate of 2 feet per second. So imagine that, imagine Nanelle's a rock climber. She's up on the mountain, and she's pulling her pack up at 2 feet per second. What does that mean? Climbers, once they reach a certain height, sometimes to climb a certain mountain, it takes them 2 to 3 days, which means they need to carry stuff to camp out on the side of the cliff where they're climbing. So what they do, they set up these tents that are hanging from the cliff, and they go inside there and they sleep there the night to wait till the next day. But they carry all that in a pack or a backpack or some sort of pack with all their stuff. So it says there that they're pulling their pack up at 2 feet per second. So picture this. Imagine me. Well, Minelle. She pulls the pack up, probably with a rope. She pulls, and every time she pulls, how many feet? 2 feet. Does that make sense? She pulls 2 feet, pulls again 2 feet, and so on and so forth. Right? Can everybody picture that? Okay, so that's one situation. But then it says, the climber drops a coil of rope from directly above the pack. The height of the coil in feet for T seconds is given by this equation. So, all of a sudden, the Minelle drops a whole coil of rope down when she's pulling up her pack. So it's dropping, and that is given by which equation? So how many situations do we have here happening at that moment? 2. 1, she's pulling up stuff, and 2, she drops something else. So what does that mean? Now we're looking at a system of equations. So for this one, I want you to write example mega Q, and let's write the system. Let's see, give me the system, please. Hunter. We'll leave it in T terms for this one. 2T, and what else? All right. That is correct. That's our system. Now, to solve it, it says, at what time does the coil and rope, what time does the coil of rope hit the pack? So she's pulling up, the other rope is going down. So what does that mean? When do they hit each other? But in a graph form, what does that mean? When do they intersect? So what does that mean? Look at it. How can we solve this? Aside from graphing, look at it. What is y? So what would I write here?
Oh, substitution.
Substitution. So we write 2t equals negative 16t squared plus 175.5. So now that we're here, we have a quadratic equation, don't we?
Yes.
Okay, so what is step 1 for quadratic equations? Standard form. Is it in standard form?
No.
And it's not even equal to 0, so what do I do here?
Minus.
Minus 2t minus 2t. So my new equation is 0 equals negative 16t squared minus 2t plus 175.5. Now here we have a special situation. Look up really quick. We're almost done. We can't factor because this one's a decimal. We can't complete the square also because we have a lot of stuff going on. What would be the last resource in solving this kind of equation? The quadratic formula. So you write x equals minus b plus minus square root b squared minus 4ac over 2a. Let's see, what is a here? Negative 16. What is b? Negative 2. And what is c?
17.
And then you just substitute and find your zeros. Yes? I'll stop right there. Your home play for tonight. It's only 3 problems. What problems are they? 8, 9, and 10 from pages what? 667 and 668. There is tutoring today. If I don't see you guys tomorrow. Bye.